Now we're going to pick up with letter F, because I think the last recording cut off the end of F. So where we left off with this is that we had 5 millimoles of the acetic acid from the very beginning. We have 60 milliliters of the 0.1 molar hydroxide. And if we use stoichiometry, that leaves us with 1 millimole of that in 110 milliliters, which gives you 9.1 times 10 to the negative third molar. That's the unit there of hydroxide. Now, we also do get 5 millimoles in 110 milliliters of solution for the acetate, but that's going to be insignificant. So if you look at that concentration, it's 0.45 times 10 to the minus second. So this is 10 to the minus third. And the Kb value for that dissociation is 5.6 times 10 to the negative 10th. So the amount of hydroxide that is going to produce is minuscule in amount to the amount of hydroxide from the excess here. So this sig fig is going to override anything we would calculate from B. So we really can just ignore that whole Kb and that whole amount of acetate because there's such a large excess of base. You can't ignore it all the time, but when there's a huge excess of pure base, that amount can be eliminated. So if I take the pOH of this, that's going to give me a pOH of 2.04. Okay, I didn't write that right. So this is pOH. So 14 minus the 2.04 is going to give me a pH equal to 11.96. Okay. All right, we're going to move on to letter G. Okay, for part G, what you're going to be seeing then is that my same 5 millimoles of acetic acid. This time I have 75 milliliters of the 0.1 molar of sodium hydroxide for a total of 7.5 millimoles. So this time my 7.5 millimoles is again going to react with the 5, so 7.5 minus the 5 millimoles that we had before is going to give me an excess of 2.5 millimoles. Again, I apologize that this writing tool I'm using is not the most fabulous. So we have 2.5 millimoles in a total volume of 50 plus the HAC plus 75 for a total of 125 milliliters. So 2.5 divided by the 125 is going to give me a concentration of 2.0 times 10 to the negative second molar. Again, I am going to get that same 5 millimoles of acetate, but again, its concentration is so small in comparison to the pure hydroxide that I don't need to count that small amount that it's going to contribute to the base or the pH. So my pOH is then going to equal a total of 1.70. And 14 minus that 1.0 is going to give me a pH of 12.30. Again, fairly strongly basic at this point because we have an excess of a very strong base at this point. So that is your final answer in pH. And thinking about titration, this is where you're getting where it's starting to flatline at the end again. So thank you very much for your attention, and look for due dates for your problem set.